Hi, name is Ivan, and welcome to Standoff. I am certain that day 2 will actually be even more interesting than day 1. You certainly know that this standoff started yesterday. Blue team fighting it out with the red team over the city infrastructure. And their fight still continues. Lawrence Amer will present the first presentation today, and he's gonna talk about lateral movement and unique techniques of lateral movement. So please stay tuned.
Thanks for attending this event. In this talk, I'm gonna talk about unique attacks of lateral movement, which is part of reteaming simulation. Before we begin, let me introduce myself. My name is Lawrence Amer. I'm a part of team member of BWC Hong Kong. I'm doing vulnerability researching, nutrition testing, and red teaming. Also, you can follow me on my Twitter on the following identifier. So in our talk today, we're gonna talk about introduction to the lateral movement. So I'm gonna provide some ideas about what is the lateral movement, what's the phases before the lateral movement. The second chapter, we will talk about move under the radar techniques. I'm gonna demonstrate some of the techniques I have developed and also using in some operations. The third part, which is attack analysis, which is a part of blue team side. I'm gonna demonstrate how you can detect that through carbon plaque and Windows Defender MDATP. And the fourth part, which is the final one, which is creative technique. The creative techniques highlights on the mindset, how you can develop your own technique for the lateral movement. So, in introduction, in any red team operation attack life cycle, is to start by establishing a core rules of the engagement, and one step, the objectives are set up properly. So mostly the break time for any red teaming operation is just takes 2 hours less or more, starting from the initial access, persistent, and discovery. And after finalizing this breakout, which is about 3 stages, you come to the lateral movement, which is the most important part in any red teaming operation. So what is lateral movement? As a definition, what it is. So it's known as east-west movement, refers to the techniques that a cyber attack uses after gaining initial access to move deeper into a network in a search for sensitive data and other high-value assets, including other servers, workstations, or other components inside the network. After entering the network, the attacker maintains ongoing access by moving through the compromised environment and obtaining increased privileges using various tools. And of course, there are so many tools use this. I'm not going to cover most of these tools because every day there's new tool comes in, but I'm going to demonstrate some of the tools we use probably. As a summary, in a lateral movement, the attacker has already managed to overcome the perimeter. For example, the outer proactive walls of a target and has access to at least one of the network area. And then gain access into relevant network components or servers, databases, whatever. The second chapter we want to talk about is moving under the radar. In any current modern red teaming techniques, it actually requires more skills and effort for creating shell codes and even gain access to the system without being detected. Because mostly right now in any server or in any workstation on a PC, you face to do a conducting on it. It's default installed with antivirus solution. That's the minimum requirement. So it means that you have to develop your own skills, techniques to at least have this kind of capabilities. But I'm gonna highlight some of the 3 points in unique lateral movement, which really makes it very hard for the enterprise security solutions or even security product to trace you or even detect you or not able to prevent you. So the first one, which is the fileless lateral movement attack. Of course, I'm gonna to give an introduction for everything, but the fileless lateral movement attack is about executing something without the dropping file on the hard disk. That's the smallest definition for it. The second one, which is the very important one, which is like AV evasion, antivirus evasion. Without ability to bypass antivirus solutions, your attack will fail, even you are conducting a very unique one, because you have to, the shellcode you have to do, the backdoor that you develop should be not detected. If it's detected, that attack will be failed. So this is the most important step in lateral movement, that you have to bypass the antivirus. And I will recommend to, before doing that, you have to practice so much on so many products and understand them how it works, and then you can, that will help you to bypass the majority. The third one also, which is creative techniques. Creative techniques is about the mindsets. If you don't have the mindset, so then you don't have a unique style to compromise, or at least to achieve your goal in routine operation. So hopefully that will be more. That's what we're gonna cover in this talk, and let's start. Fileless east-west attacks. As I said before, it's executing or getting access into a target system without dropping files into a disk, or doesn't need a file to work in. So you have two cases: without dropping a file on the disk, or you doesn't need a file to work in. But that's not only enough, because sometimes you may executing kind of Windows command, you actually only depend on a process, but really that's not powerful. I mean, just like executing some basic commands, that will not helpful. But if you wanted to do it more dangerous, you have to put it on bat file. But adding a bat file is not a fileless attack. So that's why you may need an executable, standalone executable, or develop a script that relies on different components of Windows API. Or you have developed the technique to avoid dropping files. So you have two cases. So on our case today, I have developed through my framework, which is ZeroXSP framework. The first one, which is crafting WMI, fileless movement. And the second one, which is weaponization of a CreateProcessWithLogonW, which depends on Windows API. So let's start. What is ZeroXSP Monogos framework? The first version of ZeroXSP Monogos was only targeting privilege escalation and misconfiguration and do some auditing for the Windows environment, also Linux, the previous one. But the new one, which is only for red teaming, and also you can do it for other purposes, but I have added some modules for red teaming purposes. So it's a unique framework for cybersecurity simulation and red teaming operation, Windows auditing for new vulnerabilities, misconfiguration, and privilege escalation attacks. Replicate the techniques and the techniques of an advanced advisory in a network. So through ZeroXSP Monogos as a lateral movement module, you can hop up into another machine and execute a fileless payload by fetching it from ZeroXSP Framework Web API without dropping file into the system hard drive. As the name for this technique is called bidirectional attack. So that's how ZeroXSP, crafting WMFI fileless movement works. So let's start with a kind of more explanation for this, how it works. So before that, from the attacker machine, you go to the Node.js application, and from the Node.js application, you go to the command line interface, which is as you can see in the figure below, and you can save your own payload that you want to pass to the agent. And of course, the agent will parse the output and execute it into the machine that he's already moving to. So that is, you type your payload, or you can choose the technique from already save it once from 0xSP, and you save it. And after that, the agent will fetch it. So let's see how the agent will deal with that. So as you can see in the highlighted yellow one, we are willing to move laterally into this host name. So from the agent, we start specifying -LR, which is the module for lateral movement, and the host, which is the host you would like to move in. Of course, you need a username and the password, and the username should be in this syntax. I mean, you have to specify the domain / and then the password. And the SRV host, what it is actually the attacker IP address, because that's the one that he will communicate to fetch the payload from. So after that, he will use the HTTP bidirectional host to fetch the payload from. So let's see what has happened after executing this command. Basically, after sending that, it will do the authentication with the WMI interface and creating the process there as a task. And then the payload that fetch it from the 0xSP framework will be executed in the host that you moved in. And you will get the reverse shell, or maybe you want to do some comments or chopping other things. That depends on what you're going to do. But in this talk, I just like to demonstrate the file list movement. So this is the first part, which is crafting WMI fileless movement. So let's move to the next one, which is the weaponization of a creative process with LogonW. I think we see some of the demonstration lately how you can use this one to spawn a reverse shell, but it takes time and it really takes efforts to do that. Most of the time it will not be that stable and the shell will be detected. So what I did, I used that as a kind of technique for lateral movement, but it's also under the category of user impersonating. I mean, without going to validate, if you wanted to validate the username inside the domain, maybe you're gonna do something like run as, and that run as will do spawn you just like CMD or PowerShell thing. That's it. But in this one, you already spawning a reverse shell with the username that you already laterally move into. So let me explain you how. It's actually create a new process, and it's a primary thread. Then a new process run the specific executable file in a security context of a specific credential like user domain and the password. It can optionally load the user profile for a specific user. I thought that's also optional. So if you can see for the picture below from the Windows MSDN library, you see that I have used this API to weaponize it later on the agent. So let's go on details for it. As you see in the diagram below, it's the 0xSP monoghost agent will communicate first with the Windows API CreateProcessWithLogonW. And meanwhile, instead of just like spawning the CMD, he will also prepare one socket module. But how does that happen? When you're creating that process, you can actually redirect the output and the input of the CMD or the process into a socket and receive and send these results to a specific address you specify. So in this case, you already spawned a reverse shell. It takes some time to develop this kind of thing. It's really impeded in this way, but this is how it is. So at first, it's create a process with another user account. Then you prepare WSocket connection. Third, you handle the process output into inside socket buffer. And finally, you send and receive function using Windows Socket API. That's how comes the weaponization of create process. So basically, as you can see in the POC attached, the requirements to replicate this one, you only have to specify -r as a module, the username, and the password, and then the process that you want to spawn. I prefer to use CMD or PowerShell only if you wanted to interact with PowerShell, and then the domain of the user. Like, for example, I'm using 0xSP domain as testing. And then after that, if the username and the password are correct, he will ask you to provide your remote host, the attacker remote host, to receive the reverse shell. And of course, that reverse shell is not detected at all. So then you provide the remote host and the port, and then the agent will connect back to you. And as you can see, you already received a unique shell marked with 0xSP monogoose shell. And if you go to the home UI, you already observe that you are going from the Lawrence. You're already using another account to move in. If you're interested to go to the source code and you see how it works in details, you can navigate to this line. And it will be okay if you suggest more things for that. Now, after we conduct our both attacks, previous attack, let's try to do some attack analysis for the blue team side. The first part, I'm gonna using carbon black. Why? Because carbon black is mostly used in the EDR response product, and it's mostly of the organization using carbon black, but they also only depending on the default setting of it, or just like using some feeds. But actually carbon black without improving it database with your own emulation, it's not that helpful. So you have to improve it as much as you can. So what is carbon black? Carbon black is a cloud native endpoint security software that's designed to detect malicious behavior and to help prevent malicious file from attacking an organization. In carbon black analysis is actually draw a diagram of an executable execution. But in our attack, it's failed to detect subnode of WMI process. I mean, it's failed to actually show you what's happened. It's recorded the events, but it failed to show you what's happened. So from the blue team side, it will be very tough mission for them to detect what's happening. Especially they will see the agent and then they cannot see that there's WMI processes spawning. And what they gonna do? But actually, carbon black, and then on the next attack, or sorry, in the next slide, he is already detecting that, but as a timeline event, not as an alert or as an attack. So as you can see, if we do some manual search query in carbon black, looking for the WMI PRFC process, which is part of WMI interface that I'm dealing with, you will see that actually there's a kind of PowerShell comment. There's a kind of spawning of the PowerShell. That's how it's detected. So it means that the attack has successfully executed, but it becomes very hard for the blue team side to spot the attack on the fly, as CP used to do that with the other attacks. So actually with this kind of attack, the first one, which is WMI, I crafted it, because if you do that in a previous way, carbon black will demonstrate that, or even block it, or record the event as it is. I mean, because it's just like a normal one to detect. But that's the way how to do that in a unique way. So if we're going to do the attack analysis also with carbon black, but with the CreateProcessWithLogonW technique, it's actually failed at all to detect this one, because carbon black doesn't deal with Windows API execution. It doesn't detect what comes in with Windows API. So CreateProcessWithLogonW failed completely to be detected, And most of the EDR solution actually, not just like Carbon Black, fail to detect direct system calls. And there is an interesting resource which is provided by Autoflank about this one. It's really highlighting how this works. Now let's do attack analysis using Microsoft Defender Advanced Threat Protection. So actually Microsoft became leading in this product, and it's really an amazing product and very helpful, especially for the blue team side. And when you're doing the team operation and there's a blue team doing that on the other hand, that will be very helpful and really complete the circle. So Microsoft Defender Advanced Threat Protection is an enterprise endpoint security platform designed to help enterprise network prevent, detect, investigate, and respond to the advanced threat. So in our demonstration, we'll do an analysis of the previous attacks and then inspect MDATP timeline to catch the incident and create permanent rule for detection. Unfortunately, also, MDTF failed to raise an alert for that, but he catch it as a timeline. I mean, he's already telling you that there is a process was executed via WMI. That's very good. I mean, that's very easy. It becomes for the blue team, but it still doesn't trace that there is an alert. There's a conduct of routine technique has been conducted recently. So in this case, he also allow you to do your own detection rule, your own investigation. You can respond, investigate, and develop your own way of rules of IECs. So how you can do that? First, you have to inspect one of these events that you really see that this is related to our attack, and then you click on Hunt for related events. And when you click for this one, you will get more results about this event, what has happened. For example, after we clicking on event, you'll see there is a kind of information about the process. As you can see, he really successfully detected all the command passed, even with initial process parent file name, creation, and provided you timeline query for that, for later investigation. So what you're gonna say, you have to minimize the time. As you can see, selected event timestamp, you have to minimize that to 3 minutes. So that will make it closer for you to catch really the good query to develop your own rule for detection. So after we collect a kind of information, because Microsoft Defender Advanced Threat Protection depends on query language, it means very easy to develop your own rule. If you are good in query language, it's very easy for you. I mean, as you can see, I have specified the device event, which is the table of the detection process, and then you have to specify the action type. In my case, I'm using process created unsigned query. As additional field, I have specified is remote machine and also initial process. The rule is somehow covering kind of this attack. I mean, it's generally detect a kind of lateral movement. So, but you have to do so many testing for this one to avoid FP values ratio. So you have to, with the information before, you can use that. But just like for this, I'm just demonstrating how you can do that. And really the rule right now is working perfectly. You can even use it with your own organization. So how can I create a rule after my query is fine and the rule is already working as expected? It's very easy. Just like you have to click on create detection rule, specify detection name for your rule, frequency, which must be every hour. Severity depends on category. This is very helpful for the MITRE techniques. And you can provide description. I prefer to do that from just like copy paste the description from the MITRE. That will help you to categorize your information that you already collected. And then after you specify that and save that and replicate that tag, you will see that MTATB has raised and detected the movement. The final part in this talk, which is creative techniques. So in creative techniques, as I told you, is about how you can develop your own technique to achieve something. One of the common ways of doing lateral movement is using task scheduling, especially that's available on coupled strike. So you depend on task scheduler interface to schedule a task, and that task will allow you to laterally move to that host. It's a good one, but the previous one has been already done and it's been detected, and because it's very popular. So what I did, I have developed another framework called Revenant. You can also grab the copy from here. The idea of this one is about it's a reliable method for remotely accessing a systems via server message block SMP protocol for both joined or non-joined human computer. You can conduct that for example, joined computers, servers, workstation, or just like direct PCs, direct servers, whatever, they are not joined to the domain. Because it depends on a way of compromise, which is differently from others. So how it is, actually it's alternative to PC execution, but of course PC execution is unique in its way. So what I did different in this, it's actually upload the files or the script in any writable share. It means it doesn't need an admin share to reach that target. Any writable share, you can upload your payload, and with the help of task scheduling, as you can see in the diagram here, it will interact with the system and execute your payload after 5 seconds exactly. That's how I made it. And of course, because it's task scheduling, you can also use a kind of custom attack method. I mean, you can specify a specific time to conduct that. So it becomes more and more anonymous to do that. It's more tricky to do that. So that's the idea of Revenant. Feel free to grab a copy, and it's also developed with the free Pascal. It's very easy to compile. So let me give you a kind of a proof of concept how it works. So what it is, all you have to do, just like specify the IP address, the username, and the password, and then -s means the share name. So in case it's user, you can type user. If it's C drive, so you type C, D, whatever. Admin, that depends on what's that share that you're targeting. And then -C, you specify the binary that you would like to upload. So in my case, I'm using just like C2 binary related to Covenant, whatever. That depends on what you want. So after that, the tool will look locally what's the available drive to mount. It will mount it, and then after that, we'll mount the remote host with your local drive, like for example, as you can see here. And then after that, it will copy that payload into that share, and then in parallel, we'll communicate with that task scheduling module interface and create a task and map it to the path of the file stored in that share, and then it will be executed. So basically, it's very tricky and very creative to do lateral movement with it. And And you can also, as I told you before, you can custom the timeline for that attack. I think it's like the end of this presentation, and I hope that's very, very helpful, and thanks for your attention. And for question, you can reach me via contact as I mentioned before. Thank you.